Hey, Mr. Myes is here. How you doing today? In this video, I'm going to be going over odd and even functions. Now, don't think of odd and even functions as like 1, 3, 5, 7. Odd, not really. And don't think of even functions as 2, 4, 6, 8. Who do we appreciate, Mr. Myes says? No, not really either. They have to do more with symmetry. So what we're going to do is take a look at the symmetry. Ooh, man, tough crowd. We're going to take a look at the symmetry of graphs, and we're going to see if the function is odd, then the symmetry is going to be symmetric about the origin, and if it is even, then it's going to be symmetric about the y-axis. So let's take a look at just the definitions first. So an odd function is symmetric about the origin. And we can see what's symmetric about the origin is algebraically by looking at f of negative x is equal to negative f of x. And we'll take a look at some examples of how we can see that algebraically in just a second. An even function is symmetric about the y-axis. And symmetric about the y-axis algebraically looks like f of negative x is equal to f of x. So let's take a look at some graphs, all right? So here we can see a graph. This is just some function. I just kind of drew it up here. Goes up and then down and then back up again. Now, if we can find a value in, let's say, quadrant 4, that's the exact value, only kind of on the opposite side. On the quadrant 2, then this point, if they're kind of like mirror images, though the mirror is really maybe the line y equals x, so the mirror is there, then this is going to be called symmetric about the origin. So notice here that the x value is -1, and if the x value is -1, the y value is +1. Where over here they flip. If the x value is +1, then the y value is -1. That's where we get this function definition here. So f of -1 is going to be negative f of 1. Let's try that again. F of 1 is -1. F of -1 is just going to be the opposite, and that's what origin symmetry is. Okay, it's kind of like you flip the x. You don't really flip the x and the y, but one is the opposite of the other. Opposite being negative or positive. If it's symmetric about the y-axis, then the x and the x for its negative x is going to have the same y. Oh, that was a lot of words here. Let's try to see an example here. So if our x was 1 and our other x was -1, then we should see the exact same y value for those, +1, +1, okay? So for opposite x's, the y values are going to stay the same. For opposite x's, the y values are also opposite. That's what this one says, all right? So that's how we see it graphically. We're basically looking for, is this picture the same on opposite quadrants? Is this picture the same on adjacent quadrants? Okay, if that's the mirror, all right? So let's take a look at some examples, okay? So we'll be back with some examples. All right, here we are with practice problems. So let's take a look at these. Actually, no, these aren't practice problems. These are examples of where we would use, how we would find if something's odd or even using algebra. So first of all, okay, well, you know what, let's go and do this. So what we do is we're going to plug in, we've got to remember the formulas or the definitions from the previous, that I had up here previously. So what we're going to do is we're going to plug in negative x in our function. So anywhere we see an x, we're going to plug a negative x and then simplify that. So we're going to have negative x squared minus 3. Negative x squared is negative x times negative x. Negative x times negative x is positive x squared. So that's going to give us positive x squared minus 3. Now, notice that this looks exactly the same as f of x, right? So same thing. So we're going to say that's equal to f of x. So, since f of negative x was equal to f of x, we have the exact same thing. Once we figure that out, then the function is going to be even. even. All right, so let's take a look at another one. We're going to do the same thing, guys, same thing, all right? Plug in negative x. Anywhere we see an x. Almost missed that. There we go. Now we're going to simplify. Negative x times negative x times negative x is negative x cubed. Negative times the negative is positive. So this one actually does not look like what we started with, but if it doesn't look like what we started with, we're always going to factor out a negative, okay? No matter what, if it doesn't look like exactly what we started with, factor out a negative from the whole thing. X cubed minus x. Now, notice that this right here does look like what we started with. So in fact, this is equal to negative f of x, because this was f of x, right? It's the same thing. This one and this one. Except now we have a negative, so we put a negative. So, what am I doing? F. This is g. All right? G. What up, g? G of x, negative g of x is equal to an odd function. This is an odd function. Okay? This is odd. Well, isn't that odd? Why, yes, it is. Okay, let's take a look at a couple more examples here. So, I have, we're going to do the same thing. So, let's go ahead and plug in negative x. I'm not going to use a different color because I think you guys can figure it out with the black. Okay, so then we're going to get h of negative x is positive 3x squared plus x plus 1. Well, you know, that doesn't look like the original one either, so we're going to do what I asked you to do and take out a negative, factor it out. That doesn't look like the original one either because we got a minus and a negative there. So, it's not odd, it's not even. Guess what we call something that's neither odd nor even? Neither odd or even, right? So we just write this as neither, all right? Or neither, tomato, tomato, however you want to say it, okay? So, let's take a look at one last one. I know I'm getting really close to the camera here, okay? I'm just taking a look at my time, making sure we're not going too long, all right? Okay, let's take a look at one last one, and then I have a couple of practice problems for you to take a look at, okay? So let's go ahead and plug in negative x. And we'll simplify that. We get negative 2x over x squared minus 2. Now, this does not look like what we started with, right? We have a negative on the top. So we're going to take out we're going to factor out a negative. Now, when you factor out a negative with a rational, so when you have a numerator and a denominator, we only have to take the negative out of either the numerator or the denominator, not both. Because if you had negative divided by a negative, you take them both out, that's positive, right? So you only want to take out from either the top or the bottom. In this case, I'm going to take the top because the bottom already looks like my bottom. My bottom. Anyway, negative 2x over x squared minus 2, right? So this here is the same thing as what I started with, only negative, which means that it is odd. Yes, it's odd. This is an odd function, okay? Because this is equal to negative f of x. All right, guys, I will return with 2 practice problems. You can practice them, and then I'll quickly go over them, okay? Bye. Here we go. Practice time. Odd or even. Write it down, and then I'll go over it, okay? So I'll give you a second to pause. Seconds up. Okay, here we go. We're going to plug in negative x. And we got negative x cubed plus 2 times, plus 2 times negative x equals negative x cubed minus 2x. Factor out a negative because it doesn't look like what I had before. And I get negative f of x, which is odd. Now, here's a little trick. If you have powers that are odd, and it's a polynomial, it's probably going to be odd, okay? All right, let's take a look at h of x. So we're going to plug in negative. We're going to get x squared plus 1 over negative x cubed. Remember, we could take a negative out of the numerator or the denominator, and the whole thing is negative. And we got just a bunch of odd functions today, right? Odd. Now, one thing I'll show you too, a little trick. If you're dealing with rational functions, okay, numerator, denominator, if the numerator is odd, if the denominator is odd and the numerator is even, then the whole thing is going to be odd. In fact, if they're odd over odd, you get an even, and an even over even is also an even. Think of an even as a positive and an odd as a negative. So negative divided by negative is positive. A negative divided by a positive is a negative. Okay, that's how we come up with these little rules. Okay. All right, guys, that's it. Odd even functions. Catch you later. Bye.